Welcome, viewers, to Bodhi Unified Flow. Here we simplify complexity and amplify performance. Today, we are diving deep into a topic that is absolutely crucial for modern operations. We're exploring value stream mapping, or VSM, specifically focusing on finding inefficiencies in project lifecycles. We'll be looking at advanced VSM, including simulation and BIM, and how we are essentially evolving VSM with digital technology. It's an exciting explainer where we'll unpack how to transform those old, static project lifecycles into highly dynamic, real-time engines.
To keep us on track, here's a quick look at our agenda. We'll start with our learning objectives, then move into identifying those hidden project inefficiencies. From there, we'll explore BIM integration, jump into advanced simulation and digital twins, look at automated VSM, and finally, wrap up with our key takeaways and references.
All right, Section 1, Welcome and Learning Objectives. Let's set the stage.
So what exactly are we aiming to get out of our time together? By the end of this explainer, you're going to have a rock-solid understanding of foundational VSM concepts, giving you the tools to spot hidden waste in your own workflows. But we're not stopping at the basics. You'll also grasp how to practically integrate digital tech like building information modeling and discrete event simulation so you can evolve your operations into a true real-time system.
Moving right along to Section 2, Identifying Hidden Project Inefficiencies.
Think of value stream mapping as your ultimate diagnostic framework. It's a lean management tool that lets us meticulously document everything, every single step, every minute of wait time, and every material handoff across the entire life cycle of a project. Whether you're dealing with massive construction builds or complex design phases, mapping out this flow is the key to figuring out exactly where and why your productivity is stalling.
You know, the theoretical foundation of this whole concept actually traces its roots back to the Toyota Motor Corporation. Back then, they originally called it Material and Information Flow Mapping. And I want to emphasize, this was never just some conceptual training exercise. It was an active, highly rigorous engineering protocol they used to model the absolute ideal optimized states of production.
What makes VSM so powerful is that it forces us to be ruthless about categorizing our activities. On one hand, you have value-added activities, the actual work that drives the project forward. On the other hand, you have MUDA, which is the non-value-adding waste. Now, in complex projects, MUDA loves to hide in plain sight. We're talking about approval lags, waiting around for requests for information, staging materials twice because of site constraints, or dealing with redundant communication. VSM acts like a giant magnifying glass to expose all of that.
But here's the catch, and it's a big one. As our projects become vastly more complex, how do we actually upgrade from a static pencil and paper map to a dynamic system? You see, traditional VSM is strictly historical. It tells you exactly what happened yesterday, but it doesn't give you any real-time foresight for tomorrow.
That brings us to Section 3, Building Information Modeling Integration. This is where lean meets tech. According to the National Institute of Building Sciences, building information modeling, or BIM, is so much more than just fancy 3D drafting. It essentially provides us with a crucial, centralized platform for information exchange. It pulls us out of the world of abstract 2D flowcharts and drops us into highly detailed, collaborative visualizations of a project's physical and functional traits. So what happens when we actually combine BIM and VSM? It's honestly a game changer. By laying our value stream map directly over a building model, stakeholders can easily identify spatial conflicts, visualize where materials are moving excessively, and mitigate rework risks well before a shovel ever hits the dirt. It essentially transforms into a massive engine for error reduction.
Now for Section 4, Advanced Simulation and Digital Twins. Let's add time and prediction to the mix.
Enter Discrete Event Simulation, often called DES. This brilliant tool allows project teams to safely test all sorts of what-if scenarios. Let's say you want to completely change a structural steel delivery schedule. Well, DES lets you observe the precise impacts of that change on your overall project timeline without risking a single dollar of actual capital or causing physical delays on site.
And then we have digital twins, which elevate this concept to a whole new level by acting like a real-time GPS for your project. By utilizing these simulation capabilities, your teams can figure out the absolute most efficient sequence of tasks. You can test entirely different layout scenarios and track progress dynamically. This aligns perfectly with the ultimate goal of VSM, relentlessly streamlining processes and systematically eliminating waste.
Moving to Section 5, Automated Value Stream Mapping.
This is the future state.
Remember the old days of traditional VSM? Walking the site with a clipboard, taking endless notes, and drawing static maps? It required highly time-consuming manual updates. Well, automated VSM, or AVSM, totally flips the script. By connecting directly to your enterprise systems, like your ERP or manufacturing execution systems, AVSM dynamically calculates lead times and automatically populates those process boxes for you. It literally turns a historical map into a living, breathing dashboard.
The shift from lean diagnostics to full digital integration usually happens in distinct phases. Initially, we tackled traditional lean interventions and value classification. But then, we move straight into digital integration. As highlighted by researchers Mane and Mahaske, we can actually pull live BIM data via tools like Speckle right into Power BI dashboards. This creates seamless, automated workflows that continuously evaluate your time savings.
Now, to actually pull this off in the real world, organizations really need to follow 4 strategic priorities. First, you have to establish cross-functional frameworks that tie VSM together with platforms like BIM. Second, you've got to scale VSM beyond just the factory floor and into your administrative workflows. Third, standardize your metrics across the board. And finally, utilize collaborative contractual structures like integrated project delivery to ensure incentives are perfectly aligned across every single stakeholder.
Finally, Section 6, Key Takeaways and References. Let's wrap this up.
Let's bring it all together and review our learning objectives. We've established that VSM is your ultimate diagnostic tool for isolating hidden waste. BIM provides the centralized platform to visualize your solutions. Discrete event simulation offers a totally safe virtual environment for scenario testing. And automated VSM ties the whole package together, giving you a predictive, real-time management engine. If you really want to geek out on this and deepen your expertise, the academic papers and standards cited here provide all the rigorous foundational data we discussed today. From the early lean frameworks established by Rother and Shook, all the way to the cutting-edge digital integration studies by Awais, Mon, Mahaske, and Daijuda, I highly recommend checking these out. They are essential reading for any serious practitioner.
Thank you for joining us at Bodhi Unified Flow. I really hope this explainer has simplified the complexity of advanced project life cycles for you. Before we sign off, I want to leave you with one final, provocative question to chew on as you look at your own operations. Are your project life cycles still relying on static maps, or are you ready to evolve them into dynamic, real-time engines? Keep optimizing, and we'll see you next time.